We're going to be talking about whether a function is continuous at a point. So continuity at a point is the topic. So I have a piecewise defined function here, which means that it's in pieces, even though I don't really define it, other than we're going to be looking at this graph. Okay, so is the function continuous at x equals -6? And you can see here that there's a jump in the graph. This is not continuous. It's not continuous here at -2. It's not, because this is a vertical asymptote at x equals -2. What about x equals 2? Is the graph continuous? And no, there is a jump in the graph. There's a missing point in the graph. It's not continuous at x equals 3. It is continuous at x equals 6. This black dot right here just means a point on the graph. Now the way we write this out is like such. We first look at the limit as x approaches -6, but we have to look at the left-handed limit and the right-handed limit. If the left-handed limit is equal to the right-handed limit, then we say that the limit of f of x as x approaches -6 exists, and it's equal to whatever that number is. However, you can see that this is a 4 and this is a 6. Therefore, the limit doesn't exist because these are both unequal, or not equal. We also need to look at f of -6. We plug -6 into the function and we get -2 out. Now let's go back up here and look at our graph. We were looking at -6. Now we took the limit coming in from the left hand side, so you come in from the left hand side at -6, and as we can see here, it is going to end up being 4. Coming in from the right hand side at -6, the limit is 6. What about, so therefore, because they're two different numbers, limit doesn't exist at x equals -6. But I said, what is f of -6? So that's taking -6, plugging it into the function, and finding its corresponding y value. And because these are two open circles, means they're two undefined here, that will have to go down here. And there is a y value associated with -6, and it happens to be -2. Now we do that for all the rest of them. Looking at this one here, we can see that the limit of f of x as x approaches 6, coming in from the left hand side, is -2. Coming in from the right hand side, it's -2, and therefore the limit of f of x as x approaches 6 is also -2. Now what is f of 6? Well, because this is a solid dot and it's actually a point defined on the graph, f of 6, we look at its corresponding y value, and it is -2. So therefore f of 6 is -2. The limit of f of x as x approaches 6 is also -2. Therefore it's continuous at this point. Now I've got a table drawn up. And I've got it written out, taking the limit of -6, approaching from the left, from the right. Right, this limit, remember, doesn't exist because both these are not equal. I think I might have already talked about that. And these are some of the other points. This one here I should have probably mentioned first because it's on the far left. We were coming in from x is -8 from the left hand side. It doesn't exist because there's no graph, right, associated with it coming in from the left. Coming in from the right hand side at -8, the y value is 4. These are not equal, therefore the limit doesn't exist. However, this does exist, but then again this limit must exist for this even to be a competitor, and even then they both have to be equal. Let's look at what our criteria is for to be equal. Okay, we've got the limit as x approaches 6 coming in from the left hand side. We said it was -2. coming in from the right hand side. We said it